All right, and now for the fun part of binomial expansion and Pascal's triangle and the binomial theorem and all the fun things that you woke up this morning thinking about. This looks like a lot, but it is the exact same thing as Pascal's triangle, and we can see that right here. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, right? And so on. And so this number is found by adding these two numbers together. This number is found by adding these two numbers together, and so on with every number in the triangle. So what this can do for us is that you'll notice that these numbers are the coefficients that match up with the expansion of however many polynomials the row is. So for example, if we have x plus y cubed, this row of Pascal's triangle, the third row, this is technically the 0th row up here, just the first one. So the third row, which is right here, is 1, 3, 3, 1. So that means that the coefficients are going to be 1, 3, 3, 1 of these products. So we would do 1 times the first term. And think of these, we need to be able to think of these x's and these y's not as just the x and y variables, but as the first and the second terms. So the x, like right here, that would be the first term. So if we did x plus y squared, we would do 1 times the first term squared, not just x. So if we had 2x plus y squared, it would be 1 times 2x squared from the second row, okay? So that's big. Thinking of these examples here, the x plus y to a power, think of these x's and y's not just as variables, but as the first and the second term. And not in the way that we thought of sequence terms, but in the way that we think of binomial terms or polynomial terms. So with that being said, another thing that you might notice is that as we go from the left to the right, our x's lose powers one by one, right? So if we look in the fifth row, x plus y to the fifth, we have 1 x to the fifth plus 5 x to the fourth times y plus 10 x to the third plus 10 x to the second plus 5 x to the first, and then there's no x's at the end here. And in the opposite way, we can see that we start with 5 with the y, then we go 4 for the y to the third, y squared, y to the first, y to the 0. So the way we can think of this is that there's a power of 5 in each term, but it just depends on how it's split. So as we go from the left to the right, x's decrease their power by 1 and y's increase their power by 1. So you'll notice in the fifth row, x5, and then the next term is x4, y1, so that's a power of 5, x to the third, y squared, still a power of 5, and so on for the rest of the terms. So this can help us because if we can memorize or even figure out how to build Pascal's triangle, that's going to make it so much quicker and so much easier for us to expand polynomials like this than to do x plus y times x plus y, and then distribute in another x plus y, and then distribute in another x plus y, and doing it again. So what these polynomial coefficients can do is help us just know the coefficients, know the shared powers here, or the power splits, and solve from there. And so like I said, let's practice thinking of these as the first term and the second term. So it's not just the variables, and so let's try it with this. We're looking at x plus 1 to the third, so we're going to look at the third row. Wow, that is a faded marker. Okay. So we're looking at the third row, and our third row says our coefficients are going to be 1, 3, 3, 1. And so to multiply this out, we're going to start with simply a 1, and we're going to multiply that times our first term, which is x, and that first term is going to be raised to the third power, since this is raised to the third power. And then the second term is going to be raised to the 0th power, 0, marker cap 0, because technically, or because this is the term that is only between the x's. So only x's, or only the first term, is in this first spot. And so the second spot is where we'll have x squared y to the first, and our coefficient is 3, so plus 3 x squared, and our y, our second term in this sense, is positive 1. And then in the second spot here, we know that this is just going to be raised to the first power. So we had x raised to the third power here, x raised to the second power next, and our next term is going to be a coefficient of 3, again, as we can see up there. Multiply that by our first term to the first, multiply that by our second term to the second, and so you'll notice that we are continuing to have a power of 3 in each one of these terms. Power of 3, 2 plus 1 is 3, 1 plus 2 is 3, and last but not least, we have 1 times our second term cubed. And so when we look at this, we can simplify this down pretty easily. It's a pretty basic polynomial, and we end up with x cubed plus 3x squared plus 3x plus 1. And so when it's a simple polynomial like this, you can clearly see the row of Pascal's triangle in here. 1, 3, 3, 1, 1, 3, 3, 1. But it gets a little more confusing when we throw in negatives or different terms as the first and second term in our polynomial. So let's try this one with a negative 1 as our second term. So first off, we'll look at our coefficients. We see that our first coefficient is 1. And our first term is x, so we'll take that to the third because we're working in the third row. And then our second term is going to be negative 1, but we're not going to use that yet. So 1x cubed plus 3 first term squared, so x squared, and then the second term is just there. So we're multiplying by the second term as well. And our second term is negative 1. Then our coefficient is 3 again. We multiply by our first term once, and then by our second term twice. So we do negative 1 squared. And then lastly, we have 1 as our coefficient, second term cubed. So 1 times negative 1 cubed. Hopefully that fit on there, just barely. Okay, cool. So with this one too, we can see the pattern of the coefficients and the powers. We see the 1, 3, 3, 1, the coefficients. And then we see the switching of powers, or the first term is raised to the third, and then in the second term, the first is raised to the second, and the second is raised to the first. And then in the next one, the first term is raised to the first, second term is raised to the second to make a power of 3. And lastly, we have our second term raised to the third to maintain that power of 3. And so it's important to note again that if this was 2x minus 1 per se, each one of these x's would be 2x, because this is not just the variable x, it's the whole first term there. And so to simplify this one, we get x cubed, and then 3 times x squared times negative 1 is negative 3x squared, so minus 3x squared. And next up, 3x times 1 is just 3x, so plus 3x. And then lastly, we have a negative 1. So that's those two examples. I want you to go through and try the next two. And like I've been saying, make sure that you treat the x and y's in this formula as the first and the second terms, so that you're multiplying whatever existing coefficients are there by these Pascal triangle coefficients. So go ahead, try out examples C and D, and that finishes up our notes for Chapter 9. So we'll go over any questions you have on this in class, and then we'll keep going on a test review, and we'll get prepared for the Chapter 9 test. So thanks for tuning in again. That finishes up Chapter 9.5, finishes up Chapter 9. Thanks for sticking with me, and we'll see you soon.